So good afternoon, ladies and gentlemen. I welcome you all for today's e-conference on process digital twin for chemicals. Myself, Praveen Prashant, editor, Indian Chemical News, will be your host and moderator for today's e-conference. Chemical and petrochemical companies see process digital twin as the most building block for the digital transformation of the chemical industry. With this in the background, we have chosen this topic of process digital twin for chemicals. The presenting partner for the e-conference is AVEVA, a global leader in industrial software, which drives digital transformation for industrial organizations, managing complex operational processes. Next slide. The speakers for today's e-conference, we have Mr. Bhaskaran Rajagopalan, Senior Vice President, Design and Technology, Aarti Industries Limited. Dr. Jan Willets, Vice President, Simulation and Learning, AVEVA. Mr. Darren Gong, Solution Consultant Lead, Process Simulation, APAC, AVEVA. Mr. Partha Sood, General Manager, Technology, Haldia Petrochemicals Limited. Mr. Atul Govil, CTO and Head, India Glycols Limited. Just a brief about the speakers. Mr. Bhaskaran Rajagopalan, he is a high-end technocrat in the chemical engineering with around 24 years of experience in pharma and specialty chemical sector. Extensive experience in technology development, safety, and scale-up data generation, process design for batch and continuous plants. We have Dr. Jan Willets. He is responsible for the global management of the process design, simulation, and learning business. He has over 30 years of experience applying process simulation and optimization solutions in the process industry. Jan is an established industry thought leader who has published dozens of articles in industry-leading publications over the years. Mr. Darren Gong, he has 16 plus years of experience in technical sales, solution, consulting, business management for providing software products and solutions to oil and gas, petrochemical, chemical, energy, power industries, specialized in the industrial digital transformation solutions. He has worked with leading solution suppliers like AVEVA, Schneider Electric, Invensys, Sulzer, and Aspen Technology. Partha Sood, technology professional with more than 32 years of experience in petrochemicals, fertilizers, chemicals, and plastics, skilled in technology selection, design configuration study, project appraisal and feasibility studies, experience in greenfield and brownfield revamp project execution, process optimization, process engineering, energy management and benchmarking studies, responsible for new technology process automation and digital collaboration initiatives for Haldia Petrochemicals. Atul Govil, Chief Transformation Officer with India Glycols. He's a graduate engineer with dual degree in marketing and HR management, has a strong practical domain experience in SAP, S4HANA implementation and support IT infra, cloud, and cybersecurity management. Strong hands-on experience in implementing IoT in complex batch and process plants to drive operational excellence and profitability improvement initiatives with a cross-functional team. So let me, before I ask Jan Willets, Vice President Simulation and Learning, AVEVA, to give his presentation, I would request all delegates to be alert and type their questions in the Q&A window at any point of time, and we will take the questions after we finish the panel discussion. So over to Dr. Jan Willets for the presentation.
Thank you. Let me share my screen. Okay, please confirm you can see the screen.
Yeah, we can see the screen. So please go ahead.
Great. So thank you everybody that has taken the time out of your busy day to join us for this e-webinar. It's a great pleasure and a great honor to be here and to share with you sort of my perspective on how we see the process digital twin being used in the chemical manufacturing industry. And as we all go through a digital transformation over the coming years, how this really is a cornerstone of such an initiative. So just to quickly build upon the introduction. So, I am responsible for the process and simulation business here at AVEVA. My contact details are at the end of the presentation, and I will be more than happy to sort of communicate with everybody after the meeting as appropriate, if there are any additional questions or follow-ups that people want to have. So I'm going to begin by just providing my sort of viewpoint on some of what I see as industry challenges and opportunities that we face today in the chemical industry. Being aware of these industry challenges and opportunities, I will then sort of go into some of the solutions that we have here at AVEVA that can help that are actually helping our clients be successful on their digital transformation and energy transition journeys that are ongoing today. I'll share with you some success stories that we have of people applying these different technologies in different ways before wrapping up with some concluding comments. So in terms of industry challenges and opportunities, focusing in, although the title says global, I want to focus in on the Asia Pacific region specifically, since this webinar is targeted for those customers in those regions. And Asia Pacific, has become an important player in this market. So there's some very interesting statistics on this slide that I think are very important to share. That 45% of the global chemical manufacturing business and 120 million chemical jobs are based in the Asia Pacific region. The majority of new investment in facilities are also happening in this region. Whether the chemical customer is Asian based or European based or American based, everybody has plants and facilities in the region. On the right hand side, we can actually see the based on revenue, the largest customers in the industry, with BASF and Dow at the top, but with obviously other customers from the Asia Pacific region sort of up there and front and foremost, key players in this area. Obviously, the sort of globe is facing some interesting and challenges with the COVID pandemic that is ongoing and continues to be ongoing. But there are sort of other sort of big effects that are ongoing at the moment. Climate change obviously is front and foremost on everybody's minds. And with the recent COP26 conference in Glasgow, again, that has brought this, back to the, minds of many people. But, within the chemical industry and with the oil and gas industry, many, companies are taking the lead in terms of driving, initiatives, investments, changing the way we do business to be, lower our carbon footprint. And particularly in the chemical industry, to innovate new circular economy commodity chemicals. And I'm going to say a little bit more about that. So if we actually look at how the industry is responding to climate change and to the need for more sort of reusable and cleaner chemicals, we see that sort of three major transitions happening at the same time. So we first of all see the circular economy drivers. We see the energy transition happening at the same time. And we're also seeing a large workforce transition. And I'm going to use these three themes during this presentation to highlight some of the sort of important ways that the industry will be changing in the coming years, and the different technologies that can be applied. So again, based on different industry analyst papers and so forth, again, interesting statistic on this slide is that, some analysts estimate that by 2050, nearly 60% of plastics productions could be based on reuse and recycling. I attended a similar webinar recently given by Covestro, which is one of the major polymer manufacturers. And the person that was speaking at the time said that we've had 70 years to, the core commodity chemicals that are used today by, across industry. Those processes were invented 70 years ago. And over the last 70 years, we've fine-tuned and optimized those processes. But we're now in a position with the circular economy that we have to invent new commodity chemicals and bring those to market in a fraction of the time that we've had to fine-tune over the 70 years our existing commodity chemicals. So the industry is up, doing a lot of research and development at the moment, innovating new polymers, new chemicals, new circular economy chemicals. And this has to be done in a much shorter time frame and optimized and sort of made competitive in a much narrower time. So we need to design away waste and pollution and rapidly invest to drive efficiency and operational excellence. Obviously, the bulk chemicals is one area, but we also have to decarbonize. We have to lower the carbon footprint of the industry. This is being driven by climate change and by, as I mentioned, the industry is taking the lead and making net zero commitments to sort of lower the footprint to net zero over the next 20 to 30 years. And this is, again, going to dramatically change the chemical industry. It's going to, once again, drive efficiency and operational excellence. Carbon capture and storage will become very, very important, perhaps 20 to 50 times more larger than it is today. And also a shift to a hydrogen economy or a lower carbon footprint, with over $150 billion of capital investment already earmarked and under either FEED or further along in the asset life cycle. And that number, I think, is going to grow very rapidly. And then the workforce transition, in the sort of developing economies, there is an aging workforce. I think there was the estimate that 50% of the people in the developed economies are going to be retiring in the next sort of 20 years, within the next 20 years. And then where all the new investment is going on in the developing economies, there's going to be a new workforce coming on board. And that workforce today has very different expectations around technology, how they want to go about their job, the contribution they make to the world. So we're going to see a workforce transition be a key element in sort of digital transformation and technology embracing as we move forward. So we do have these three large transitions all happening at the same time. It's almost like a perfect storm. We need to address these. So in terms of addressing those three industry challenges, I think there are 4 areas where we will see a large amount of drive from the industry. Obviously, one is sustainability, and that is sort of meeting the sort of climate challenge. The need, if we're going to spend, $500 billion, or even $1 trillion, we need to make sure that those capital projects that get executed are executed a lot more efficiently than they have been in the past on previous projects. We need to drive engineering productivity. We need to take the workforce that we have today that is always challenged to do more with less and dramatically improve engineering productivity. And then we need to sort of address the workforce transition. So in terms of, perhaps I'll sort of very quickly focus in on the capital project efficiency and then the engineering productivity, since I've already mentioned the workforce transition and sustainability. So if we actually look at the execution of capital projects in the past, on average, there is a sort of 30 to 40% average schedule and budget overrun on capital projects. Now, if you do a quick 30 to 40% calculation on $1 trillion, you don't need to be a math wizard to figure out that that's hundreds of billions of dollars. So we need to drive capital project efficiency and look for ways to do that. And then engineering productivity. If we actually look at the way that we perhaps interact with the internet today and use search engines and book hotels when we go on vacations, we're a lot more digital. We are in the sort of commerce industry in the way we interact with the internet than we are when we're at work. And it's estimated that nearly 50% of the time of process engineers is spent looking for data on data sheets, P&IDs that are printed out and stacked in the corner of a room, and PFDs and so forth. We need to drive engineering productivity and make engineering data as readily available as perhaps the price of a hotel in Bangalore. So we need to change the way that we drive workforce productivity. So this is going to be all around, technology is going to empower digital transformation of the process industries. So we have the Industry 4.0 transition that's been going on for approximately 10 years now. And there are really 9 technology pillars associated with Industry 4.0. And we have a sort of a picture of that at the bottom, and some of them, big data, augmented reality, IIoT, cloud computing, cybersecurity, etc. I think we're all very familiar with the sort of latest technologies that sort of comprise and will be integrated into a digital transformation journey. And that is, being combined with the digital twin. So those technologies sort of come together with the digital twin. And I'm going to say a little bit more about the digital twin shortly. So Industry 4.0 plus the digital twin is driving digital transformation. And just so we're all on the same page when we're talking about digital transformation, this is the confluence of tools, work processes, and people, and bringing those 3 circles together to drive sort of improved productivity, project capital efficiency, and so forth, workforce transition, and new sustainable technologies that will improve the world. So in terms of the 4 pillars that I've sort of focused in so far, if we work smarter with digital transformation, we can design and implement the sustainable plants of the future, whether it's oil and gas, whether it's chemicals. So, for sustainability, if we do this right as an industry, if we step up to the plate and we look at, implementing technology that we can actually calculate the carbon footprint, the environmental impact of a new design, we can actually make sure that the design of that new process is the most efficient possible, so that we're, we're driving change by not just looking at energy efficiency, we're also looking at environmental footprint. So we can do a 20% reduction in materials wastage and a 30% improvement in real-time collaboration on, sustainable processes. For capital project efficiency, making sure that we use the digital twin and use a simulation model early on in the project lifecycle can have a dramatic impact on the net final completion of a capital project. The earlier we identify design issues and challenges, the cheaper it is to actually make corrections to those mistakes. So, that is absolutely key to shortening project life cycles and also reducing CapEx overruns on capital projects. Being able to share data across engineering disciplines and raise the maturity of the feed process so that we get fewer change orders during the capital project. These are some of the things that we can accomplish with digital transformation, empowered by a process digital twin. For engineering efficiency, we can implement tools and technologies that make process engineering data readily available, as I mentioned earlier, just as easy as it is to book a hotel room or find the price of a hotel room in Bangalore. And we need improved process simulation tools that are much more efficient. So, and I'm going to say a little bit more about this shortly, which is that, you know, a single tool can dramatically, you know, can be reused and reused and reused through the process lifecycle. So we don't have 3 or 4 different simulation models used by different people at different phases of the project lifecycle. And then if we can use these same tools to train people and get them up the learning curve, we can get plants online sooner, get to product in tank, to nameplate capacity faster with less waste produced. So, you know, implementing the types of technologies that I'm going to touch upon shortly can have a dramatic impact on the execution of the planned capital projects and even existing brownfield projects. So how is AVEVA bringing value to the table? What are the different technologies that we're rolling out in response to this drive on the part of our customers for digital transformation? So I just want to make sure that we're all on the same page when, you know, the term digital twin is used frequently by many different people. And as a term, it means different things to different people. So I want to give you the perspective that when we talk about the digital twin at AVEVA, we look at it again from 3 pillars. If we actually look, there is the plant digital twin, which is the process data. All of the data sources, whether it's the existing data coming from a PI historian, or if it's the actual design data coming from a new capital project, you know, that data represents what the plant is doing today. You know, how was it designed? What is the valve size? What is the pipe length, etc. There is also the simulation, the process digital twin, which is the model of the process. So this is a first principles or a sort of a database model that gives the cause and effect relationships on how the plant will behave once built and designed. And then the third pillar is all around visualizing or accessing the data. So it's essentially, how do you visualize the data in the plant and also the results? And how do you sort of derive insight and knowledge from the process digital twin and make that information available to the connected worker? So collaboration, learning, and guidance is all pulled together by the digital twin. And today we're going to be talking around, you know, we are going to be addressing the process digital twin, which is here at AVEVA, we look at it from sort of 2 angles. There are physics-driven models, or first principles models, and then sort of data-driven or empirical AI models. And we sort of are tackling this from many different aspects. There are steady state models, dynamic models, models for the pipelines, the utilities, planning and scheduling models, online models for performance monitoring and real-time optimization. And these can be combined with neural net models, AI models, deep reinforcement learning, etc., to combine the best of both worlds and make sure that we have the best possible model representation of a process. And that, again, you know, is all geared towards driving digital transformation. So the way that we've tackled this at AVEVA is that we've taken a step back. We are an established simulation company. We've been in business delivering simulation software to companies for 50 years. But we took a step back and we looked at the chemical industry. We looked at the the energy transition that's going to go on as part of a response to climate change. And we've designed a new platform from the ground up that is using the very latest technologies. And this platform is called AVEVA Process Simulation. And it has been designed from the ground up to be multi-core, cloud ready, with a role-based user interface and completely open and scalable and customizable to your particular process. So we wrote the code from scratch. This is not a rework of an existing product. And it's been designed to deliver the process digital twin for the chemical industry and the renewables world. And it runs in different run modes: design, rating, and dynamic mode. There are multiple libraries for process intensification, for environmental impact, for economic impact. It is completely AI enabled, and we can have one single process model for the entire asset life cycle across all the different engineering disciplines involved in a capital project. And most importantly, it's been designed to be used by the next generation of process engineers, the so-called Gen X, Gen Y, and I think we're even up to Gen Z now. So it's got groundbreaking ease of use, instantaneous results, an intuitive user interface. So it's ready to meet the demands of the chemical industry, and it's ready to future-proof the environment with sustainable solutions. And most importantly, easy to learn and use. At a recent, some recent work done at Cal Poly Pomona in California, the professor at Cal Poly presented and ran through some coursework with 3 different simulators, 2 established simulators and a Viva process simulation, challenged the students to do some coursework, and then got feedback on those 3 different simulators. And of the class size of 33, 31 out of 33 reported back that a Viva process simulation was completely better, completely new, much better environment for doing their process engineering calculations. So that was a very positive reinforcement from a local university and from our next generation of workforce. So to keep this moving, I'm not going to spend too much time on some of these individual features, but we have this new AVEVA process simulation, a next generation solution that builds upon what I just said about being designed from the ground up for the next generation of workers. I am going to play, a key part of today's presentation is around sustainability, and I will show, play a video that shows some of the capabilities of AVEVA process simulation and how it can be used to drive a more sustainable future. And hopefully you can, the sound will come across. We tested this before the meeting, so I'm confident it will work.
This is an example of a Q-mean production process that's included as a standard example with the AVEVA process simulation. As you can see, it's a complex process with many waste, utility, product, and raw material streams. Because of that, it's a great example of the type of process we'd want to calculate sustainability metrics for. As part of our proof of concept design, we've added 16 new sustainability metrics to this simulation. These are calculated in a new sustainability dashboard model within AVEVA process simulation. We've added efficiency indicators like the environmental factor, carbon efficiency, and water intensity of the process. There are also new environmental indicators, including the global warming potential, total methane emissions, and photochemical oxidation potential of the process. This new model also calculates the resource energy efficiency. With the new sustainability metrics shown here, we can now get the full picture of how sustainable this process is. Other process simulators may have clunky ways of calculating these values from spreadsheets, but those are really difficult to maintain. Our POC includes all these calculations right in AVEVA process simulation. This opens doors to process optimization and real-time monitoring that's simply not possible in any other tool. As a result, we can optimize the process to improve any of these metrics. For example, we may wish to minimize the methane or CO2 emissions from the process, and we can do this using these new metrics and the built-in optimization features in AVEVA process simulation. The final part of this POC is creating a real-time dashboard that our customers can use for advanced visualization of their process sustainability. Let's switch to dynamics mode now and start running. We'll use this dynamic run to imitate the type of real-time data that we could get from a DCS or through external connections with tools like OSI Pi. On the left of our dashboard, you can see a radar plot with the sustainability metrics we calculated earlier. Notice how the radar plot is changing in real time as the conditions in our plant are changing. On the right, we can see in real time our overall CO2 and methane emissions from the process. This real-time plotting has also been made possible as part of our POC. We want to enable our customers to visualize their sustainability metrics just like they would any other KPI for their process. And this dashboard and the real-time reporting really allows for that.
Okay, so again, there's just an example of, what the software looks like and how it's been, we've sort of tackled AVEVA process simulation very much with sustainability, front and foremost in the design. So I think I'm probably talking a little bit much on. So anyway, the application of AVEVA process simulation can be used throughout the process lifecycle. So a model built in AVEVA process simulation can be used at the conceptual design and feed stage. That model then matures for detailed design. The model can then be used to support virtual commissioning and training, online performance monitoring, and even closed loop real-time optimization. And I'm actually going to walk through examples of how our customers are using this software today throughout this process lifecycle. So although this is relatively new software focused on specific industries, we have a lot of the top 50 companies already adopting this as a simulation platform of choice, including the companies that are shown on this screen. There are additional companies that are using this that we actually don't have their permission to put the logo up at this time, but we're seeing very rapid adoption by some of the sort of big players in the oil and gas and chemical industry. So I'm going to walk through just very quickly some examples over the next 5 minutes, and then we'll go to the panel discussion. So if we actually look at the conceptual design and feed stage, it's all around fast evaluation and coming up with a sustainable design at the optimal CapEx investment requirements. So in the video I showed a short while ago, we showed you the sort of the sustainability indexes and how we can view those in real time, from a performance monitoring. But it's also, it can be used during the design process. So again, as our engineers showed in the video, you can actually optimize for, reducing CO2 emissions or methane emissions, given the constraints that you want to make a certain amount of product of a certain product quality. So we've got the economics library. We can also factor in the economic calculations of CapEx and OpEx. That's built into the software. And we can also use it with AI models for processes that cannot be modeled. And we can actually use an AI agent to actually do those calculations for us that will do multi-constraint optimization, considering both environmental and economic. We have this prototyped at the moment. We have clients actually sort of doing this independent of us with their own AI agents. And we do see this as being a big growth engine going forward, actually using AI to do the sort of the design of experiments of new different processes to improve the way that we operate. Also built into the software is a full renewables library, including wind, solar, power transmission lines, power inverters, electrolyzers, hydrogen liquefaction that operates in steady state. You can look at the impact of wind on the solar. You can look at the impact of the wind on the wind farm. You can look at the impact of the diurnal cycle on the solar panels and so forth, and look at the overall dynamic effect on your process. We're also seeing people use AVEVA process simulation for the detailed design, so taking those models to the next level of fidelity. And Fluor is one customer that is using AVEVA process simulation today. And just some of the highlights from this slide, that they were actually able from taking the training class to getting valued work from their engineers in just 2 weeks. And they were sort of confirming that they were actually able to very, very quickly do design alternatives against multiple objectives in a very efficient and rapid manner. And then Probon Engineering in Latin America, again, some data points from their work using AVEVA process simulation. They estimated that it was a 60% reduction in project implementation time. And it took 15% fewer engineering hours to do the simulation and the design. As we move sort of through the asset lifecycle, once we move from design into operations, we want to be able to use that same process digital twin in an online mode and in a for performance monitoring and also for real-time optimization. So, oops, got a little animation there. So we take when it comes to online applications, we have the real plant passing real-time data to a Pi server and serving that information up to the customer. But we can interface a Viva process simulation to the Pi data server, take real-time data, calculate things such as those efficiency factor, global warming potential, and those other environmental KPIs, or sort of product quality, pass that information and serve that up to the end customer. So again, this is a customer. We are in the process of getting their approval to use their logo and their name. But this is a customer that is using a Viva process simulation online today in their acrylonitrile trial plant, very successfully to optimize their utilities, saving hundreds of thousands of dollars a year from putting their design model online for real-time optimization. And we're working with Aramco on using a Viva process simulation for predictive analytic optimization or model-led reliability, where they are using a Viva process simulation models to monitor the performance of over 2,000 pieces of rotating equipment across their enterprise. And this is an ongoing project that kicked off in the last year and will be delivered in the coming year. So to sort of conclude my presentation, I've probably gone 5 minutes over. Apologies for that. But basically, the industry is facing a lot of challenges from different aspects, from the need for a circular economy, from climate change and the need for new sustainables, and from a workforce transition. We have designed a product here that we're sort of sharing with you today called a Viva process simulation. That is a next generation solution that can help address these. And the the demonstration or the little video I showed shows the sort of sustainability library, the economics library. These are all features that have either just been added into the release that went out a couple of weeks ago, or will be coming out in the next release early in 2022. So with that, that concludes my presentation, and I'll hand it back to Pravin.
Thank you, Dr. Jan Willis. And you brought a very interesting perspective of the three transitions: the circular economy, the energy transition, and workforce transition. And you also said that there are more transitions which will happen, which we are not aware about. But these will definitely make a lot of disruptions in the market. With this in the background, now let me open the panel discussion. And I would ask Mr. Bhaskaran Rajagopalan. Sir, what are the challenges and opportunities that you see are there for the chemical industry, whether in India, whether APAC, or whether global, and how do you see that, sir? Over to Mr. Bhaskaran Rajagopalan.
Yeah, thanks, Prashant. So I think I'm very happy to be here, honored to be here. And I think Dr. Jan Willis set a nice context in terms of what is there for us in terms of process digital twin for the chemical industry. So if we look out, the chemical sector holds a significant position in the Indian economy, accounting for almost 7% of the GDP and about 14% in the overall index of industrial production. So, and also same, India also ranks 4th in Asia and then 6th in the world in terms of the chemical sales, which roughly around, we can say, 80 USD billions in 2018. So if you look at the challenges, if we want to say the challenges, the chemical sector in India, as Dr. Jan also talks about that, the plants are becoming larger and larger, and also once it's larger, it becomes, the complexity also becomes larger and larger. So, and there are all departments, all the chemical companies in India are bound to stretch to bring new products. So that is one of the key challenges. So another important thing is now time to market also is going to be very important. So it's from the stage of incipient to things, time to market is also a key challenge, which is right now. It is their competitiveness. It is increasing day by day. So many players are coming into the game. So the competitiveness is increasing a lot. At the same time, as Dr. also talked about, we have to also, in the pressure of making a lower carbon footprint and circular economy, commodity chemicals we need to bring. This is also one of the challenges what right now we are facing. And apart from that, the right talent. So as he talked about, many of the older workforce are getting retired, the new workforce are coming out. The talent and the skills are also going to be one of the challenges. Apart from that, friends, if you look out in India, the R&D, how much we are spending is almost 2-3% of the total turnover, you can say, which is 5 times lesser than the Western companies or multinational companies. So India, in average, we are spending 1.5 billion, I think 2 years back. So the amount of R&D spend is very, very less compared to other multinationals. And also we have also complex regulatory issues, also is one of the key factors.
I think it's background noise. Please
Hello?
continue.
Yeah, please go ahead, sir.
Background noise, I think.
Yeah. So these are the challenges what in India we are facing. If you look out challenges globally, is environmental, social governance, and sustainability is one of the key things. And then Internet of Things, IoT, what Dr. talks about, this is also one of the key challenges. But in general, if you look out what perspective chemical industry as a whole, the challenges what they're facing is in terms of leadership, and the thing is the clarity on when to begin the digital transformation journey and who owns it in the organization, who leads the initiative. This is also one of the key challenges. There are too many silo digital projects is happening at once without knowing their organization principles. And also companies are taking the technology in the first mentality, okay, AI, or it is something a new process digital twin, or no, it all gives value at long term, not immediately. So these are some mentality which is sets into the framework of the people. So these are the challenges I can say. But as I said, if there is a challenges and threats are there, there are no opportunities also with us for the chemical industries. So opportunities, if we look out, as far as India is concerned, almost we can look out almost 20 billion USD of exports and imports, I can say we are doing in a year. So a lot of opportunities are available with us. The trade conflicts have erupted around the world, especially among China. So because of the stricter environmental norms and tighter financing and consolidation in China, it has a huge opportunity for chemical companies in India. So, and then another key challenge, our opportunity is the digital technology has established itself to a next level of enhance our efficiency and productivity. So chemical companies also started prioritizing the environmental sustainability to protect a long-term shareholder value while continuing to comply with the local regulations. So digital twin can accelerate the sustainable journey. So several global and oil majors are turning their sights on downstream chemical opportunities. This may increase the focus on petrochemicals in India, and higher investments in the sector could see easy feedstock challenges and boost cell efficiency. That's what about my side, Prashant.
Thank you, Bhaskaranji. I would request Partha Sood sir, if you can talk about or add on whatever Mr. Bhaskaran has said on the challenges and the opportunities side, and you can also focus on the petrochemical side because you look after Haldia Petrochemical. So over to Mr. Partha Sood sir.
Very good afternoon to all my fellow panelists, respected fellow panelists, the participants, the organizer, and of course the Indian Chemical News Network, which probably is the 4th or 5th time I'm appearing. So it is a pleasant place to talk about before I move into my sharing my perspective about this particular subject, see, I'll give you a brief, little background of Haldia Petrochemicals. You all know that Haldia Petrochemicals is a TCG group of company, and very recently, the last year, 2020, the TCG has acquired the Lamas technology. So Lamas is a global technology licensor acknowledged across sectors as far as petrochemical refining is concerned. So they do have a technology know-how. Now we have also another sister company, is a TCG Digital. So they are into different segments. They're the digital. They have a digital footprint across different sectors. So they were into before. Now, very recently, after acquisition of Lamas, the new company which has been formed is a Lamas Digital. It is basically a joint venture company of TCG Digital and Lamas. So it is a newborn baby trying to roll out its wings across the globe with all the fundamentals in it, and they have a very niche product like MQ, which it can run through across the fleet of any organization, whether it is a chemical, petrochemical, refinery, whatever you name it. So we have one end, we have technology licensor who has the process knowledge, know-how, and every bit of information that you need to design a plant. And other side, we have a digital footprint embedded to it. So with that background, with that background, the joint effort is being translated in Haldia Petrochemicals, and we are implementing digital footprint across our disciplines, across the functions. That is the kind of background I'm coming from. So now coming back to the point that we talked about, and where Mr. Rajagopalan and of course Dr. Dan has talked about at length. So I'll give you a little bit different perspective. See, what India is different from the rest of the world as far as petrochemicals and the specialties chemicals footprint we are going to have. So see, the new, I'll go into the basics. The first with the basics, that very recently all of us are aware that government of India has rolled out a new education policy. This policy primarily aims at building new talent pool and to become a India self-sufficient in terms of your newest technologies, and of course from homegrown and indigenous R&D effort. That's on the big push that all of us we see. And given that background, you can also find out, you also know that for the year 2020-21, there is a negative GDP growth of -9%, which has translated in the year of 2021. We see it as about to average 10%. So there is a shift. This shift has happened, and these entail a lot of opportunities as far as India is concerned. Government of India has lined out 1.4 trillion trillion US dollars into the infrastructure spending. The $1.4 trillion investment means a lot to chemical and petrochemical industries. So with that, in the year last year, the chemical market demand was $178 billion the last year. This year and the year by 2025, we expect the market demand outlay expected to be $300 billion. So you can imagine the quantum of the volume that we are referring, and this gives enormous opportunity as far as whether it's a chemical, petrochemical, refining. I'm talking about only the petrochemical and chemical industries, not touching the refineries. So where so you think about it, and how if I see the segmental penetration of the entire chemical industry per se. the pharmaceuticals and API and others put together, biotech together, it is around 19%. Petrochemicals 19%. Specialty is running very high, it is 21%. And the other the bulk chemicals is 25%. Fertilizer around 15%. So so what I'm saying is, given this kind of magnitude, and every year the India needs one big cracker of 1000 KTA. So there's a kind of investment India needs. That's why you are finding that so many projects are being announced. And it is, unless if we do not do, the India doesn't do, the rest of the world will do, and we need to import. That's a big difference. That makes a huge difference. So therefore, not only the year of 2021 and the push of this GDP growth will continue to be very on the high scale till 2025. There's the projection saying it is 7.2% for the India on an average. So whereas the world average is 3.5, so we are going to have a double digit. So we need a lot of chemicals, petrochemicals, and when you do that, now you come back to what kind of petrochemicals we have, what kind of we do not have. So the pharma is a leading, that all of us we know. The education sector is proliferating. The healthcare is booming. So all these things put together, we need more and chemicals and niche chemicals, and more and more of this kind of investment is needed. And I find there is a huge benefit. We do have, there are certain the refineries, they are integrating in a different way. So the O2C, the oil to chemicals becoming another new paradigm that we need to have in order to be sustainable. So in order to have that, government of India is also planning to build 4 PCPIRs, so that will boost the investment destination, attract the investment in a manner, in a more concerted and coherent manner. So this gives us lot of room to maneuver the industrial growth, and particularly penetration of petrochemicals in India and specialty pharmaceuticals. So I find lot of opportunities going forward, and all the major players, they are trying to build in their setups in India. So therefore I see India is gradually becoming a more and more of a durable investment destination. So with that, I leave it to the fellow panelists. So this is my take as far as India is concerned. I think a lot of opportunities going ahead.
Thank you, Partha Sur, sir. With that into background, let me ask Atul Govind, CTO and Head, SAP and IT India Glycos Limited. So with that into background, sir, how do you see the chemical industry acceleration strategy with respect to digital transformation and the role of process simulation technologies in digital transformation? So over to Mr. Atul Govind.
Hi, thanks, Praveen. I think let me also thank Dr. Yan for this fantastic presentation which we had. I think one important topic which I want to also highlight as regards chemicals is that one is, we talk about the circular economy, we talk about productivity, production efficiencies, energy optimizations. I think these are important, but as much these are important, I think there's another aspect which is more important, is around the safety aspect, plant safety aspect. And I think we'll all agree that Industry 4.0 is no longer a buzzword, and considering the pandemic situation, wherein we had lockdowns, we had the social distancing norms, physical distancing norms, I think most companies of mid and large size are actually rushing to either build, implement, or if they have some platforms already in place, they are scaling it up to basically create a digital manufacturing environment, leveraging technologies like IoT, AI, ML, robotics. And the core theme is to basically create a connected manufacturing setup. Okay. And if I were to highlight, as I said earlier, that chemicals, particularly in this part of the world, till so far, it was more around labor arbitrage. That Asia was considered as a hub for chemicals manufacturing. Most Western world entities always thought that because there were issues around basically soil erosions and other issues, environmental pollution norms and other things. So at some point of time, those issues were there. But now, even in India and also in neighboring countries, we find there is a lot of noise and a lot of buzz around having sustainable production norms and other aspects. So what is important is that we need to have a visibility on not just around production numbers or energy consumptions, but also looking at aspects around fugitive emissions, so to say. And all that is not possible with traditional control systems and traditional ERP systems and decision support systems. So, and it's in this context what we see this term digital twin, which we just learned and which we heard from Dr. Yan. I think that's come up in a very big manner, and there are companies which are scouting and looking at implementing these solutions. And just to simplify, because we as India Glycols, I represent India Glycols, we are primarily into chemicals, specialty chemicals. We are into industrial gases. We are also into pharma and alcohol. We make liquor as well. So we are primarily chemicals, specialty chemicals. That's how we started earlier. So since inception, we've adopted automation. All those PLCs, GCS control systems, SCADA systems were in place. And on top of it, in the last 3-4 years, we have started adopting IoT in a big way, and not just for energy related aspects, but also for process operations as well. And for both for process and batch plants, we've set up IoT systems. And what we really find is that going further, digital twin, which actually stands for a digital or a computerized version of a product, or it could be an equipment or a process. It actually, if you were to look at it, it's like when you talk about language of business. What is language of business? It's around currency. Okay, from a finance standpoint, that's how you call it language of business. Likewise, when you talk about language of operations or language of maintenance, it's digital twin is the easiest and the most simplified representation of the process state. It gives you an accurate state of not just the physical object, it also provides an insight about its operating parameters, its properties, and sometimes if it is the material handling equipment or such equipment wherein the geo position also needs to be factored, so it will give you that as well. So I think these are interesting topics which are now gaining traction, and the reason being that now you find cheaper computing power and awareness, and you also have skill sets which can consume that the whole technology. Considering that now you have these millennials and the digital natives who are joining the workforce, so they are finding these representations far more easy to understand, to learn how to operate the plant than to go on the shop floor and do physically and learn everything on a physical state. So I think that's broadly, I just wanted to highlight, Praveen, and I think I have more pointers, but maybe let the other panelists also.
We will come back to you, sir, in the second round. And so thank you, Atul. Now let me come to Darren Gong. Before I come to Darren Gong, I would request all delegates, if you have any Q&A, please type those questions on the Q&A window so that we can take it up after the panel discussion. And I think we have an eminent set of panelists here. both from India as well as outside India, authority on this particular subject of digital twin. So it will definitely clear all your doubts at the end of the session. So please keep on typing your questions. Darren, wanted to know from you, there is a lot of, to a certain extent, Dr. Jan Willets explained in his presentation about, say, process digital twin. So what I needed from you is what it can do for Indian chemical companies. So over to Darren Gong.
Yeah.
Or
Thanks,
what are the benefits
Praveen.
that we can get? So if you can talk about the benefits, that would be good for the audience out here.
Yeah, I think the benefits of, or let's say further expansion of the, a little expansion of the benefits that the chemical industry can get from this digital transformation by leveraging on tools or technologies like a digital twin is that, firstly, I think it's a golden opportunity for the entire industry to accelerate their technologies investment and adoption under the gravity of the huge yet the diverse, hardcore market demands in the recent years. So as I said, with all these cutting edge technologies and future-proof, technologies that the industry can complete their R&D cycle in a much shorter time, so that they become more agile and flexibility as being market oriented rather than being technology, constrained, so that they become more competitive in the short term and the long term as well. For example, they become more profound and compliant with the future global trends, including the circular economies, renewable energy, and sustainability that the industry has to focus in the next 30, 40 years as well. And at the same time, attracting the benefits, let's say the sponsorship and attention from the society, from the government, and and from the private and the government investments as well. And then not to mention, this will also benefits of the workforce growth or talent retention in the industry as well, so that the young people are more interested to join the chemical engineering industry and work here because of better benefits, because of the ease of their work, enabled by the better technology also things as well. I think this is the general benefits that the entire industry can get.
Thank you, Mr. Darren Gong. Now I come to Dr. Jan Willets. Sir, there is a lot of buzz on sustainability goals, also for chemical as well as petrochemical companies. So wanted to understand from you, sir, what are some of the considerations around planned CapEx expenditures that can minimize the likelihood of success for investment strategies to meet sustainability goals? So your views, Dr. Jan Willets.
Sure. Yeah, and actually, I want to build upon the comments by some of the other panelists because, in the slides I presented at the beginning of the meeting, I was, and I mentioned 1 trillion investment. That was in sort of green hydrogen, which is a very small fraction of the total investment. And my fellow panelists that were talking about the investments in chemical, petrochemical plants in India, those numbers dwarf, much, much larger than the numbers I had on my slides. So I need to rethink my messaging a little bit and update those slides. So I appreciate that input. So, if we're spending trillions of dollars, as an industry and in the region, I think I sort of want to reiterate a couple of points that I made in the presentation. So, we just executed a project for a greenfield with a customer in the US, which was a greenfield ethylene cracker and some polymer plants associated with that ethylene cracker. And this was a customer that sort of took a slightly different perspective. And they did embrace the process digital twin, and they did embrace modeling. And we worked with them to build a very detailed process simulation model very early on in the process life cycle. And we were able to identify quite a few issues in the initial design through the use of modeling and looking at the dynamic modeling of the process that if those issues had propagated forward and gone and only been discovered during the commissioning phase, there would have been, actually weeks or potentially months of delay on the final delivery of that project. So, so some of the things that I remember, the plants today are highly integrated. And, if you make a mistake in the utilities and if we think about the multiple levels of steam headers that run across the facility, if you get those steam headers designed wrong and you can't provide all the steam that you need for the different, pillars of the plant, the polymer plants and the ethylene cracker, then you're not going to be able to sort of operate that plant. So if you actually get that design, check the dynamics early on, you can, we eliminated those design issues. We found some issues with the fans, and we actually found some issues with the planned startup procedure, where the startup gas, they were going to use ethane instead of, as the purge gas to begin the ethylene cracker. And when they did this study during the early design phase, the startup of that ethylene cracker with a big ethane purge would have been much longer than if they actually charged the process with ethylene itself. So they were actually able to identify that they would need to have ethylene on site for the first startup of this plant. And they were actually able to sort of put in the rail cars to bring in that ethylene just to support the initial startup. So so to answer the question, what can we do to be smarter, is that we can apply the process digital twin early on in the life cycle. You will spend more money. It will cost you more, but the savings are dramatically significant, because if you, depending upon the process, of course, the profit on a plant can be $1 million a day. It varies by it varies, of course, significantly. But if you can trim 2 weeks off a startup, that can easily be worth $14 million. And a process digital twin doesn't cost anywhere near that. So that's very important to consider. And then being able to sort of carry that process digital twin into a virtual controls checkout. Again, back to the plant, the Greenfield plant that was constructed in the US, that digital twin was used for controls checkout. And they were actually, this was, the control company was Emerson, and they went through the FAT for the control system. And they were actually able, we then applied the dynamic model overlaid with the control system and go through a plant startup and shutdown and look at all of the auxiliary systems and how they would interact. And the customer was actually able to find over 1,000 issues that they were able to correct in the control logic. Again, before, while the plant was under construction, they were purging errors from the controls DCS database. And I'm not trying to say that Emerson is a bad control company. When you design a complex control strategy for an ethylene plant and 4 polymer plants, there are going to be some control issues that are just present. And you can either eliminate those control issues during live commissioning, or you can do it on a virtual plant and save weeks on commissioning time later. And then finally, that digital twin can be carried forward to prepare the operators for operation on day one. And again, this facility that we're talking about, they're actually, a couple of the pillars are actually up and running now over the last couple of months, but they've been training operators for the last year on how this plant is going to behave. So when it was, when I visited the site and there was mud everywhere and construction going on, I was able to go to the control room and attend a training session for those operators, when it was just a construction site outside, and those operators were getting smarter and smarter. So, there are so many different ways that we can dramatically impact all of this investment that is going on and do this investment smarter than we've done it in the past.
Thank you, Dr. Jan Willets. Now let me come to the second track, and this question is not easy for all the chemical companies as well as petrochemical companies. So the question is, what should chemical/petrochemical companies do in terms of assessing and choosing a digital transformation approach that best suits them? So how easy or difficult, Atulji, it is for you when you are planning to do an assessment with respect to a digital transformation approach?
Yeah, I think that's an important consideration, because ultimately, while we may talk about great technologies and new age technologies, it's extremely important to create a business case. And just to highlight and give you an example that there are these 3-4 pointers which are extremely important. One specifically is, what is the purpose? So what is the purpose of that initiative or that project? Is it that the technology is now available, so we deploy it, or is it to highlight any predictive or any descriptive parameters? How it will actually, whether it will help in driving higher throughput, achieve higher energy optimized numbers, or higher yield, so to say. So the purpose has to be extremely clear. And like in our case, while we started the project for the IoT setup in operations. So as Dr. Yan also mentioned, so any chemical or any petrochemical nature plant, you would have these utilities, you would have other plants, one plant feeding the other, and these are all connected. But then most of these subunits would have their own separate control systems. So having a connected plant gives you a visibility, and also if there is any upset in upstream or downstream of any unit, you know that what could be the possible consequence. And it also helps you segregate issues and identify that what to address, because sometimes if there is an upset, it takes a while to narrow down that what caused the problem. Was it something internal? Sometimes there are external issues because of heavy rainfall, maybe, and there is a poor insulation in the steam line. That may cause the steam temperatures to go down, okay? And because of which there could be an upset in the plant. So identifying and drawing correlations is extremely important. So as I said, purpose has to be clear. Then why do you think that particular initiative is important? Whether it is with using that initiative, digital initiative, you will be able to exploit any opportunities for optimization, or whether you think that you have to make sure that the plant operations is you find that the leadership level or the plant operators are superannuating, and now that the newer age workforce is joining in, you are finding it difficult for them to operate, and because of which you want to standardize processes or maybe templatize to that extent, so that it becomes easier for the new inducted team members to learn and be able to contribute to safe operations. So you will have that business case has to be created, the importance. And importantly, any chemical plant or such units, earlier the concept was around building a plant and operating. And then if you talk about this aspect from a consultant angle, then build, operate, and transfer, BOT it used to be. Now it's about building. Of course, you have to build a setup, and in most brownfield plants, the build part is already generally taken care. But then, while you have an existing plant, there are opportunities, and there are always a situation to scale up. That you need to replace one unit, or one pump, or one reactor with another reactor because of aging issues, because of maybe inefficiencies related issues. So if you have a digital model of that equipment, then you know what are the inherent issues which you faced, and then you can factor it in the new purchase, and accordingly make the procurement more data driven. So going beyond building and operating, you are now, the focus is around enhancement. How do you enhance the whole operations? How do you make it more efficient, so that the cost per unit goes down, And of course, in addition to that, you make sure that from an emission standpoint, from a sustainability standpoint, you are able to track that if there are any losses, then how to plug those losses. Because unless you have a manual spotlight, a data-driven spotlight on the losses, if you can't zoom into that, you can't address it. It's like unless you are able to measure something, you can't address it. And then importantly, why now? Why should we do it? Do it now? So I think, as I mentioned, so identify the critical success factors, understand the KPIs of the unit, understand which of these KPIs are being tracked manually, which are being done through systems, and then I also understand that whether I give you an example about boilers. In boilers, you consume coal. Coal is the prices of coal have skyrocketed in the last few months. Many of us would know already. And in this, at this juncture, it's so important that your boiler efficiencies are at the most optimal levels at all times, 24/7, not just because one shift operator is excellent. So you only do during that 8 hours, you get excellent efficiencies, but it's important to have a 24/7 view. So, and in most plants, boiler efficiency calculation is done on a manual reconciliation basis. So if you were to automate it, using these digital twins or IoTs and such models and technologies, you would be able to then continually see that at this juncture what went wrong, so that you are able to plug that, and such data-driven aspects and factors then will make a business case which can then be taken to the senior leadership, top leadership, for due approvals and implementation. I think that's a brief and a practical insight I just wanted to highlight from you.
Thanks, Atulji. I would request Bhaskaranji, you take care of design and technology, and for designing, say, digital transformation or choosing a digital transformation is also a very complicated task. Where to start, and what processes to start, and how to move ahead. So, your views, sir.
Yeah. So before going to what other individual companies should do, let me talk about what Aarti does. So to just give a background, Aarti is a leading Indian manufacturer of specialty chemicals and pharmaceuticals. We manufacture chemicals used in the downstream manufacturing of pharma, agro, additives, polymers, surfactants, pigments, and dyes. So on. So if you look at what we are doing is, so as Dr. Yan also talks about, there is a data available. There is a data. So now how to get this data and analyze this data to do it better, to get back in terms of the productivity, in terms of the reliability, how to do it better. So what we do is, we have our IP21, which is called a data historian. So collect all the information of the data, and then you perform into data analytic tools. We have a lot of analytical tools or AI tools are available. I'll tell you some typical simple examples to understand for the people. Say, for example, a classic example of an evaporator, a multi-effect evaporator. You all knows that multi-effect evaporator depends on so many factors. One is on the concentration, one is on the temperatures, and the pressure. So how to control so many parameters effectively in order to get the productivity, in order to be energy efficient, because in the evaporator, a lot of steam is required, a lot of energy is required. So how to integrate all those things? So what is important is, so what we are trying to look out is, you have a DCS system which captures the data from the plant to show you what other data are available. Then it can pass on to the data analytical tool, which will enhance and give back your data to such a way that what sort of temperature, pressure you can able to control better in order to get the throughput better and order to be energy efficient. This is a simple example what we try to do. So like that, a lot of examples we are also attempting on this to bring into it. So as a lot of people have talked about, our panel people have talked about, a successful digital transformation strategy requires the organization to ask itself three fundamental important questions. Why does the company need to transform? And what do they need to transform? And how they can transform? This is the basic questions what you have to ask before transforming to the digital one. The digital transforming approach for any organization, what you have to look at, aligning the transformation goals with the digital technologies, little bit be flexible and dynamic, get experts on board who are expert into those kind of IoT, and then be prepared for issues and go for a phased implementation of the plan. Rather than touching upon everything, go for a phase-wise manner. So now we have a lot of options for choosing the digital transformation strategies. One is experimentations, upgradation, and enhancement, what sort of things you have to do. And the creativity, that is optimizing the digital services, and then security, and then move fast with their agile mindset. So get to the market quickly with the core functionality and select products accordingly. This is one of the key important factors. If I want to do a closing point, so digital thing is an important tool to deliver the products that have a less impact on the environment, enabling improved process design, and also better manufacturing insights and better operational integrity. Hence, the integration of sustainability targets and business goals will be transformed for the chemical companies, definitely. So companies need to be creative, not out of choice, but out of necessity. So to participate, to paraphrase the famous quote, necessity is the mother of digital transformation. When it comes to digital transformation, strategies, agility, flexibility, and collaboration are the key components for a successful processes. So digitalization, now or never. It's a time to make progress in digitalization when there is no limit to waste. That only decision to make it whether we advance and transform or whether we get lost along the way, we should prefer the former. So in the end, it is the next normal.
So Partha sir, if you can add on whatever our two speakers, Atulji and Bhaskaranji has said, and once you are through, we will take the views of Dr. Jan Willets and Darren Gong and then open it up for Q&A. We are already running late, so I would request you to just add on what these people have said, and if they have missed any point on that part.
So just the digital twin, what it is basically mean is, to me, just I'll take a minute to what it is basically, where from it has come. Digital twin was basically, the father of digital twin was Dr. Michael Greaves. The concept came in 2002, and finally the concept was implemented in NASA in 2010, where a spacecraft was to be, the conceptualized and given its proper shape and understanding inside what is happening. So it is basically a representation of a physical system. So while conceptualizing it, what we need to do is a simulation is the backbone of any kind of process. I'm going into the core process part of it. It is the reaction kinetics, thermodynamics, is the molecular interactions, and it is the energy and material balance, how a system runs, and is a process chemistry built into it. So as a result, what you are trying to see is that this process, the complexity, you are trying to synthesize in a manner which gives you the best, and optimum, safer, and the compact design, so that the process become much more acceptable and easy to operate, and all kind of things together. This is the whole heart of the process. And when you do that, so you now bring it to the what level? You can do it on a unit level or on an asset level, or then you gradually expand this. So Dr. Dan has given a lot of insightful information based on his background. So where, this process engineering, the what stage you were in and where you were, and this gives you even the other, which I didn't talk about it, the many other industry 4.0, the technology tools that are available, the air, wear, is everything put together. You are going to make a compact design at a least cost and least carbon footprint. That's very, very fundamental. Least energy consumption. So that is the driving force. So these things, without these, I think gone are the days that you do on a paper and try to do some kind of calculation, and there is no kind of interaction between the different discipline, different interdiscipline, as well as the functions. So this gives the process digital twin, whether you take it from the process, then you move into the engineering. So entire flow sheet, entire engineering design can be done in a manner at a least cost and less time. That is the beauty of the design perspective. Now coming into operational perspective, you get all these data that the the IP20 or not the data historian, you have the model, you have the boundary, and then you are bringing the operational data, equipment data, process data. You're trying to bring it everything put together. You are what you are basically getting. You are getting stimulus. These are the area I need to control pressure. I need to control firing. I need to control steam dynamics. So these are the things is going to give lot of avenues which otherwise we have never think of reaching there. That is the beauty of digital footprint that we as an organization like Haldia Petrochemicals that we have undertaken, going to take a much bigger role. And I urge the entire industrial fraternity to utilize this. Otherwise, we will not survive. Then comes the sustainability. One incident, safety incident, process hazards, everything can be built on it. So this is a big thing which we were not. I'll say that we had the basic wisdom, but this human being has a different different kind of dynamics in it, different state of mind that we run through. But the computer, the program, it never gives you that kind of it doesn't get tired of. So as long as you get the right kind of data, it gives you right kind of analytics, it gives you insights. Based on that, you get the stimulus, then you take action and see the response. So this cycle, feedback loop should continue. That is what the essence, from the design and to the operations, and use all this energy, all this insightful knowledge for training people. And it is the game changer for any company who is to become successful, trouble free, incident free going forward. That's a take that I have.
Thank you, Partha Sood, sir. Darren, you have heard all the three people who represent chemical and petrochemical companies. So, and they have talked about challenges with respect to in terms of designing and what kind of things that needs to be taken. So, how do you see in terms of challenges in terms of implementation as a partner?
Yeah,
whatever they have talked.
That's been.
We will come to Dr. Jan Willets, and he will talk about from a longer term perspective, and he will talk about achieving with respect to sustainability and carbon net zero initiatives in the next 5 years. So sure. First to Darren and then to Dr. Jan Willets.
Okay, it has been excellent comments and the ideas from my panelists, my peer panelists, in the past 30 minutes. I think it's a really great information. It's a brainstorming from the user side, from the industry side. I would like to further elaborate a little bit more from the technology side as well, because I've seen Mr. Bhaskaran and Partha and Atul, and even my co-worker, my colleague, Dr. Ian Willets, talking about the assessment and the selection of the digital transformation, and all the way to the deployment and adoption of digital twin, digital transformation technology and the tools as well. So actually, this is related to a lot of questions that we see in the chat window as well. So some people are asking how to differentiate the digital twin from a process simulation. By looking at a digital transformation, what should I learn and keep an eye on? And also, what if I have existing automation and simulation solutions and digital solutions, and how do I further or better leverage on these existing investments to complete my digital transformation journey, all sorts of things. So all these are related to the fundamental question: what makes a qualified process digital twin as a minimum requirement or definition of a digital process digital twin from technology point of view in the first place. Then in reality, after solving this fundamental minimum requirements, then different companies have a different specific business demands can have their own add-ons and customization on top of that as well. So my understanding is for this minimum requirements of a process digital twin, it has 3 aspects. So number one is from a business side, So this process digital twin technology has to satisfy the customer's business demands. It's supposed to be able to provide the users with the process information, instantaneously and on the real time as well, either in the middle of a design, for greenfield project, or in the middle of operation for the brownfield projects as well. So it really depends on the nature of the problems that the customer are facing and they're trying to solve as well. And this kind of real-time supply of the process information can be used for the optimization purpose, and also they can serve not only they can serve for other functional stakeholders business activity purpose as well. For example, they can be used for the operational control, for the technical service function blocks, and also they can be become a part of the necessary data inputs to the supply chain maintenance as well, for them to make the real-time decisions on the analytics and take actions as well. So in reality, a lot of process engineers traditionally, they have to spend 70% of their time on tuning and updating the process simulation modules before they can actually spend the rest of the 30% of their time on the real chemical engineering work by studying on the temperature, pressure, flow rate, heat exchanger, duty, dissolution coefficient, compressor turbine, all sorts of things as well. So this becomes a real challenge for the industry, to translate or convert from a process simulation tool to a process digital twin. So that means that this kind of a self-tuning and automatic execution of a self-tuning and update function, in terms of the simulation technology, becomes one of the key qualifiers before it can be called a process digital twin. And one step further, this real-time information should not just serve the purpose of the present, which is now, but it should all the way project its use into the past and the future as well, in a sense that such a regularly reconciled and tuned and updated process information can be used as a training data to feed and train the solutions like machine learning and artificial intelligence to learn from the past and work for the future. So that the things like predictives, prescriptions, prognostics, and preventives can be achieved as well. This is the first point. The second point is from a user point of view. My colleague, Dr. Ian Willis, mentioned generation X, Y, and Z. So nowadays, generation X are retiring rapidly, and most of the users, in the next 20, 30 years, who will use and benefit from technologies like a process digital twin, will be that generation Y and Z. And these users, they expect faster, easier, and cooler, user experience, because they believe the only way to maximize their personal productivity is to love what they do and do what you love. So the tools must be modernized and cool. No coding, no twisting, that kind of thing. Just like back to 20 years ago, iPhone combined multiple functions like a phone, a beeper, a gamer, MP3 player, music player, and a GPS, all sorts of things into one piece of a device. And then 15 years ago, iPad came onto the stage. And 10 years ago, like YouTube and Facebook. And 5 years ago, Instagram. And then nowadays, people are talking about a metaverse as well. So these things, are really the things that a new generation are used to, and they desperately need for their work, for their life as well. And from companies' point of view, the same. Most of companies nowadays, they prefer to have their own IT/OT independency. That means they want to build their own, engineering hub, not just a technical service team, but one step further is a technological service team. This requires such a digital twin technology to have a down-to-the-earth kind of UI/UX to make it possible for the customers who are willing to invest and build a centralized, competency team around the digital twin technology to achieve the technological self-sufficiency and the sustainability as well. So these 2 points, again, around the user experience, the ease of use, users' self-ecosystem becomes a key qualifier, for process digital twin technology before it can be called so. Last but not least is the technology itself. So as Dr. Ian Willis mentioned, a lot of chemical processes were invented back to 70 years ago. And a lot of mainstream process simulation tools in the industry were invented back to, let's say, 40, 30 years ago, back in the 80s or early 90s as well. So the time when these process simulation tools were invented, they were aiming to solve, and they were good enough to solve the chemical processing problems, which are older than them as well.
Then would request 30 seconds because.
Yeah, sure. So that means that we need a next generation process simulation technology before it can be called a process digital twin that is built from the ground, take the goods and from the past and get rid of the bad from the past, giving user the full freedom and the flexibility to do what they want to do in a better and a different way, and to do things that they could not do before as well. So this is all I want to say from the technical.
Thanks, Darren. Dr. Yan, if you can be short and precise so that we can take up the remaining questions which has not been answered. So over to Dr. Yan.
Yeah, happy to do that. So just just to reframe the question very quickly, what are the challenges?
Yeah, the challenges and opportunities with respect to sustainability and carbon net zero initiatives for the chemicals industry in the next 5 years.
Okay, thank you. Yeah, so I don't think it's overly complicated. The investment will be required, but if we look at it from the bottom up, existing companies, existing brownfield facilities have to look at reducing methane emissions. And that's detecting, measuring, and mitigating any fugitive emissions that are from existing facilities, and replace or upgrade high emitting equipment. So I would call that basic housekeeping on the current facilities. Then we have to look at ways that we can reduce carbon dioxide emissions from facilities. Obviously, carbon dioxide is a greenhouse gas, less potent than methane, but much more prevalent. So looking at opportunities to improve energy efficiency, putting in flare gas recovery systems and other ways to reduce or eliminate flaring. There's a lot of discussion going on right now in the industry about electrification as a source of heat, as opposed to burning methane or sort of fuel gas. And then cogeneration is obviously a big shift in the industry today. So reducing carbon dioxide. We can't totally reduce carbon dioxide, so we have to capture carbon dioxide. Carbon capture, utilization, and storage, I think, is going to be key going forward. There's a lot of companies, a lot of startup companies with new solvents that are sort of pushing into this field. And I think, per the International Energy Agency, I think the number is it's like 30 or 40, maybe even 50 times more carbon capture capability or volume is required to meet the 1.5 degree temperature raise. So there's going to be a lot of investment in carbon capture, I see, in the future. And then just lower carbon, accelerating decarbonization, I think, is going to be key, which is all around the hydrogen economy, wind, solar, green ammonia, green hydrogen, etc. I think those are the things that we need to do as an industry. And then just in terms of the opportunity, very quickly, I spent a good 40 minutes talking about how the process digital twin provides knowledge and insight. With knowledge and insight, you can make decisions. You understand the cause and effect relationship. So the opportunity is around digital transformation and the process digital twin as the focus of today's discussion. Of course, there are many other opportunities out there.
Thank you. Let me now take up the questions. The first question is from Dr. R.B. Patel, but he's talking about China is manufacturing almost all the chemicals and supply to most of the part of the world. How are they managing or taking environment? I think there are a lot of things which are happening in terms, they are also closing some of the plants because of the Olympics, and they are trying to be very aggressive on the environment part. So let me skip that. Future of Subham Nale talks about future of digitalization in chemical industry. I think all our speakers talked about in detail on that part. So let me also skip that. Now I come to Mr. Pratap Singh, and he's talking about, please give a perspective as how the accuracy and time for doing a feed project like ethylene cracker can be optimized. So Dr. Jan Willets, will you take this?
I'm happy to take it. Sorry, I was actually looking for that question.
Okay. So you have got the, I've given you the right question, sir.
Yeah. So, so for an ethylene, how do we improve the feed for an ethylene? Is that the question?
Yes.
Yeah. So, obviously, for ethylene processes today, I think the most common or prevalent process digital twin for the cracking process is the Spiro software from Technip Energies. Spiro is integrated with products from AVEVA, including Pro2, Romeo. We have not integrated it with AVEVA process simulation today, but the tools exist today to be able to model a process. And then I guess my answer to the question is begin your modeling journey early. Don't wait until you must do process simulation, with Spiro, with AVEVA products, and with other simulation products early on in the process lifecycle, as early as possible. And then you have the most knowledge and insight, and with that most knowledge and insight, you can look at operability, controllability, equipment sizes, bottlenecks, and things like that to do things properly.
And one additional question is, at the time of feed, one has around or max 30% of engineering. How AVEVA process simulation can support to reduce the resource/cost for doing the feed work?
Yeah. So if you look at all the disciplines involved in a feed, you've got utility engineers, flare engineers, you've got the controls engineers, you've got the rotating equipment, mechanical engineers, process engineers. In a perfect world, and we're moving towards that perfect world, all of those simulation engineers will be working off the same simulation platform and the same process simulation model. So, we can build the utilities model inside of AVEVA processes simulation. We can build the flaring system. We can build the rotating equipment. We can put the controls on. We can do the process design in design mode or rating mode. All of that is possible. So if you have a single simulation platform, a single model for all of the different disciplines in the engineering, then you're not building a model in one piece of software to model the utilities and a different model in a different piece of software to model the flare, etc. And from that, you get engineering efficiency. So I'll leave it at that. There are other things I could say.
Okay. Darren, there is a question for you. How can we use digital tools to optimize process during development stage? And any particular digital tool that you may quote as a reference? Short answers.
Yeah, well, as I said, process digital twin is able to provide users with real-time information either in the design or in the operation as well. And this real-time information from the design, from operation in terms of process, in terms of not only the temperature, pressure, flow rate, but the equipment status, equipment sizing, all sorts of things, becomes synchronized across the entire workflow, across multiple stakeholders or functional blocks as well. This is the largest benefit that users can get from a process digital twin by having an integrated and a seamlessly integrated workflow, so that they reduce the number of iterations required, reduce the number of troubleshooting required, reduce the number of trials and errors required, all sorts of things as well.
Thank you, Darren. There is a question, I think it would be relevant for Dr. Jan Willets. Yes, Kumar Dange is talking about if he's looking at masters in chemical engineering with respect to digitalization, what course should he opt for? So I think we were talking about talent management, lack of talent. So he's saying that if I'm looking at doing masters in chemical engineering with respect to digitalization, what would be the ideal course for him? So any suggestions, sir?
That's a challenging question. Before I answer that question, I just want to, I'm really enjoying this conversation, and I think we're going to struggle to get to all of the answers. In the chat, I've actually put my email address at the bottom.
I saw that.
Yeah, so please, anybody that we don't get an answer, or you do want to follow up with more questions, feel free to reach out to me.
Prasanna,
so- yeah.
yeah, let me take the whatever I can, another 3-4, and then I will wind
Well,
up.
I was just going to say, I mean, just in answer to the question about a master's degree, I mean, I think, there's a lot of sustainability, I think, is going to be key going forward. There's going to be a lot of job opportunities in that. So any masters with an emphasis on sustainability, I think would be key, and also data science. So, process simulation and, can be a first principles model or a data model. I think both bring value. So data science and environmental, I think if I were you, and beginning my career and doing my graduate work, I would look in those two spaces, I think.
Thank you, sir. Prasanna Kopa, India moving from conventional way to operating to bring up digital twin level challenges, trained resources, equipment, automation, integration. I think all our speakers talked about it. Only I would like to take the second part, which is saying how long would it take to reach optimized levels? Atulji, any answer, sir? How long does it take to reach the optimized levels? You have done a few experiments, and few implementations. So, any idea, sir?
Yeah. Hi. So actually, no, there is always. First of all, you need to create something. You need to first create and have those right connectivity, those sensors interface, and then once you have the interconnected systems, then you come into the optimized mode. But how much time it will take, it depends upon to what degree the current sensorization is there currently. To what degree you have implemented process control systems in the setup. And even if you have process control systems, are they interoperable? Are you able to get data out of it? Do you have some open standards like OPC through which you can pull out data? So all that will factor. But I can tell you, if you were to start with a decently instrumented setup, I think anything between 3 to 6 months, you would be able to start seeing some visualizations, dashboards, and thereafter, of course, visual optimization opportunities, at least the low-hanging fruits you can start achieving from the 5th, 6th month onwards. That's what I broadly see. And that's what we have also seen internally as well.
Good, I think, experienced people, and they have what we can say, given their views. Sir, there is one question on Kamaldeep Singh is talking about cybersecurity. So, Partha Sood, sir, any views? I would request very short answers, sir. We have already, if you can, we can't hear you, sir.
The cybersecurity, I leave it to somebody else who is, if you ask me any other, process or design or any digitalization, I'll be able to answer. Cybersecurity is not my core.
Okay, Bhaskaran, sir, any answer, or Atulji?
I think if I hear you right, you want to know from cybersecurity aspects, what are the preventive measures we need to take, or is the question different?
He is saying that with more connected world and digital twin becoming part of digital strategy, how do we handle cybersecurity, particularly when Government of India has announced air gap between OT and IT network for all power companies, and it may get applicable for chemical as well.
No, I agree. I think that's the basic premise. Digital twin or not, any interface which we want to build across OT and IT systems, there has to be those cybersecurity controls and measures in place. And it will not be easy, and it's always great and better to engage with a cybersecurity consultant on OT, rather than thinking that the integration partner who would give you the platform for these digital twins, rather than reaching out to these consulting partners, it's always good to go out to an OT consultant. So what I want to highlight is, like in our case, we chose one of the leading entities. I can name it for the sake of guidance, so that people also understand that what could be possible opportunities and options. We chose Siemens for the industrial, the networking part and the cybersecurity part. We could have gone to the likes of any other players, the IT players. But because the IT players, they would not have an understanding of the proprietary control systems. So it's always better that you reach out to experts and then stitch the whole cybersecurity framework, be it the networking part, be it setting up the VLANs, and maybe setting up firewalls to ensure that there is you kind of have a DMZ, a demilitarized zone set up within the whole data flow.
Yeah, if I may add something, this is actually one of the outstanding challenges that APAC, chemical industries or the entire oil and gas industries is facing compared to North America and Europe, where there's a much more unified policy about cybersecurity and international laws, also the things as well. But in APAC, there are so many countries having their own regulations and policies and the laws, legislations about cybersecurity, or sort of things. So we need a more international collaboration among the APAC communities here. This is from one point. The second point is the digital twin technology or digital transformation technology will have to enable the smooth and seamless transition between the machine control and the human control process in chemical plant as well. So in the event of a cyber security attack, all sorts of things, the operators, the engineers can quickly take back the control of the process, from the automation system and ensure the safety of the plants as well. And that requires not only the technology level, but the workforce training level as well. So that's what I want to say.
So I would request one key takeaway from all the speakers, and then I will thank all my delegates and speakers. So Atulji, any last key takeaway?
No, I think I just want to share one specific highlight, and I'll take 30 seconds. So till so far, digital was focused on optimizing the backend systems. You had these ERP systems, CRM systems, and HRMS and other systems. Now I think it's about convergence of digital, not just in these backend systems, but driving and creating differentiating value in the manufacturing set of operations, supply chain aspects. And there is so much of value to be unlocked, unimaginable. I see at least 20 to 30% CAGR growth in the coming 2-3 years on these technologies.
Bhaskaranji, your last view. I would request everybody to be short.
Yeah. So as earlier as discussed about, it is a need of our hour, and it's now or never. So it is a right time to invest our strategy in terms of the transformation, and also choose the right path and right selection, and utilize it in terms of getting the productivity, getting the sustainability in all terms. That's what I would mainly ask.
Thank you, Bhaskaranji. Partha Sood sir, your 30 seconds, not 20 seconds.
Yeah, I'll say that when you're planning for a greenfield project, start building the basic infrastructural need so that you can start from zero, design stage, keep all the trails, and then come up, build the 3D model, and utilize this learning, the whole journey, for training people. And when you come into operation, utilize this for updating them and translate them, refine it, and you take out the best out of only the expenditures you have done for minimizing your carbon footprint and energy index for the complex. And this is it's only a journey, and it is only a continue to learn. That is the you cannot say that I have started digitalization means that is the end of it. You will find out a new kind of challenges coming up. It is a continuation, it is a continual learning.
Okay.
That's all I'll take it. Enjoy the journey, that's all.
Darren Gong.
Yeah, I completely agree with Partha, what he said. So digitalization or digital twin is not an end, it's not a point solution. It's a journey. So it's just like when people start using Microsoft Windows, 40 years ago, and they start using iPhone 20 years ago. This digital twin is the Windows, is the iPhone in our chemical industrial world. So let's quickly adopt that. Sooner or later, you have to, and let's do it as soon as possible, and choose best future-proof technology and vendor to work with. Thank you.
Dr. Jan Willets, your last word.
Yeah, so I'm gonna, the last words of my co-panelists, I think, sort of cover everything from some key messages around digital and digital transformation. My closing statement is I want to thank my fellow panelists and similarly all the participants. I can see we have a good slurry of participants in the meeting, and I really want to take time to thank everybody. This has been great questions in the chat, good dialogue, and it's time well spent for me, and I greatly appreciate that you've invested time in this as well.
Thank you. I would like to thank my presenting partner, Aviva. I would like to thank all my speakers, Mr. Bhaskaran Rajagopalan, Senior Vice President, Design and Technology, Aarti Industries Limited. Dr. Jan Willets, Vice President, Simulation and Learning, Aviva. He's still awake in California, and I think it's what, 3:30, sir, for you?
3:30
trying to educate us about this new technology, which will have a lot of impact, and the transition that you talked about. It's very simple and clear, 3 transitions, and we all see that transition coming and banging us right, so that we are all awake moving forward. Mr. Darren Gong, Solution, he has to also take sleep from Singapore. Solution Consultant Lead, Process Simulation, APAC, Aviva. Mr. Partha Sood from Haldia, General Manager, Technology, Haldia Petrochemicals Limited. Mr. Atul Govind, CTO and Head, he's sitting very next to me in Noida. CTO and Head, SAP and IT, India Glycols Limited. So many thanks to all my speakers. A big clap for all of them to educate us on this, what we can say, very important subject, very topical also. Before I thank the delegates, I would like to ask them to please rate us, or please rate this e-conference, 1 being the lowest and 5 being the highest, so that we can improve upon as we move forward. So you can type in your answers at the chat window. And if there are any thoughts or anything, please feel free to write Q&A. Those questions which we have not answered, we will try to get those answers by talking to both Dr. Jan Willets and Darren Gong and give you the right answers so that we can move forward. This feedback session is also helpful in terms of planning our next sessions or the next e-conferences, or what we can say the next set of topics that we do undertake. So let me thank once again all the delegates and all our speakers, all the delegates who registered and attended for today's e-conference. Those who have not attended can look at the recorded version on indianchemicalnews.com. We do it the very next day. So you can go to our website and go to the past e-conference and look at all the videos. We also do a coverage of this. So tomorrow in the newsletter, you can find the coverage of whatever we have discussed today. That's more on a brief part of it. And for an elaborate one, you will have to listen to the recorded version. So, and let me also thank my ICN team members who did, who were very, who at the back end were able to do all these things very smoothly. Thank you for your help and support. This is Praveen Prashant signing off for now. Till then, take care and stay safe in this COVID-19 world. And so thank you, everybody, and namaste from India.